Hi, everyone, and welcome to our webinar entitled Mapping the Path of Runoff, Smarter Solutions for Reducing Nutrients in the Maumee Watershed. This webinar series called Freshwater Science is highlighting Ohio Sea Grant partnering scientists every month. Every quarter is a different focus from human health and fish farming to harmful algal blooms and human decision making, bringing applied research to the public on issues that affect our Lake Erie communities. I am Jill Gentis-Banicki from Ohio Sea Grant and Stone Laboratory, and joining me today is Dr. Kevin Chakowski, Kim Pinozzo, and Aaron Laver. Uh, Dr. Dr. Chakowski is a distinguished professor of geography and planning at the University of Toledo. His main areas of interest are remote sensing, physical geography, and K through 12 outreach. He leads a large research group investigating the use of remote sensing in water quality and urban heat island effect, as well as reaching out to K through 12 teachers and students. Dr. Chakowski, you would like to introduce Kim and Aaron?
Yeah, hi. Thanks, Jill. Hi, everyone. Yeah, so anyway, we're going to talk about the Maumee River watershed and the work we're doing at the University of Toledo, and then in partnership with GeoAce, Aaron Lavers with GeoAce, and that's out of Columbus. Kim Finazzo is a staff member at the University of Toledo who's worked on Maumee River watershed projects for a long time with me. And we're going to kind of combine two funded projects from the Ohio Department of Higher Education HABRI program. And I should mention, this is also our projects are in collaboration with Daryl Dwyer, who recently retired from the University of Toledo, Kevin Egan from economics, and then two graduate students, Tanzia and Juti. So, Kim, do you want to go to the next slide? All right. So these are four objectives that we kind of put together for today's talk. And okay, so one there, identify concentrated flow paths through field buffers, which are actually going to do later after implementing high resolution remote sensing. Adding that high resolution remote sensing to PERM3, which is the model that Aaron has developed. And then Aaron's going to talk about the PERM3 ranking of sites using a benefit cost analysis. And those sites are mainly for wetland installations or other installation of other nutrient reducing uh, projects. All right, Kim. So Kim's going to start off and talk about her work uh, with the remote sensing and GIS.
Great, thank you, Dr. C. So my primary focus on the mapping portion of this project, I was mapping drainage features and the nutrient runoff potential. In past work at ET, I've mapped land use and agricultural practices across the watershed using many different remote sensing and data fusion methods. Predominantly work on mapping agricultural land at a high resolution, the crops, crop types, rotation patterns, cover crops, applications, and various tillage practices. So I was focused with my main objective was to expand upon these past layers and add the vegetated buffer strips agricultural practice to them. This required us to map out drainage networks at a high resolution and be able to determine the types of vegetated buffer strips and other various characteristics that contribute to that. So that includes small drainage channels, infield drainage paths, lines, that flow from the field to the drainage ditch itself, and the locations where those intersect. Um, Doing so provided me an ability to incorporate the vegetated buffer strips and create the drainage or create the hotspot map regarding runoff potential, specifically for dissolved reactive phosphorus. So I'll give a little bit of information on what we used, how we did it, and the final result of that. So the first set of data that we use to identify and validate the spatial layers, it comes from the agricultural database that was collected by Dr. C and his students. This database spans from 2007 through 2026 now. I should probably update that table. But the data set consists of roadside observations for over 800 field edge locations, and many of these were revisited multiple times for different years, the same locations. 2007 through 10 includes county collected field observations, and from 2010 onward, we have expanded upon this work at UT. Primarily, we initially started with photos, geospatial locations, and records of various crop types on the fields and the tillage practices that we were able to observe. And over time, this was expanded to include soil conditions and cover crops, where eventually we ended up incorporating field edges, drainage ditches, and field buffers, and channels, and like areas of overland flow, areas where water was flowing through immediately after a rain event. So the image inputs for mapping all of these various spatial layers that we need come from high resolution aerial imagery, satellite images, and digital surface models of elevation, which are derived from LiDAR point clouds. All remote sensing inputs here are open source and available online if one could find them. If anybody ever needs that, let me know. But the majority of the high resolution aerial imagery was obtained from the Ohio Geo-Rectified Imagery Portal, Indiana GIS, and the National Aerial Imagery Program. So the elevation itself was derived from the LiDAR point clouds and original products that were provided to the USGS. And a note that when this was underway, this was before the USGS provided the 3DEP high resolution elevation data sets. So that meant we had to process all of those for 2019 ourselves, which you can see in the top right here on the map is in blue. The processing scope pretty much included two main sections. So we fused over 35,000 aerial images with the corresponding satellite data and processed that to create year-specific field boundaries, crop maps, and agricultural land. And we also processed over 71,000 tiles from 2019 for the elevation information for use in mapping those hydrologic features. So once processed, these inputs are usable to identify hydrology features at scale. So we had slope, elevation changes, and the drainage network itself, which further allowed us to improve our mapping of agricultural layers. So quickly, how did we do this? To get to the nutrient runoff potential map, we used the field level agricultural intensity layer, or the potential nutrient runoff per field, and best practices that were found on each field, which the practice reduction potential was calculated by each practice that was found within each field. Mapping was done using field data with the remote sensing classification methods and a data fusion process. This provided us with being able to improve our land classification layers that we had before, but specifically the drainage network and the drainage features were able to be extracted from the set of images to create the vegetated buffer layer, which was the final layer that we needed to create the nutrient reduction potential map. So these are the resulting layers that we had that actually incorporated into that nutrient reduction potential map, and specifically crop rotation, cover crops, tillage practices, and the buffer strips, as well as agricultural intensity. Okay, so I'll try to go through this pretty quickly, but what this looked like in practice was each practice in acres per field was calculated using a score by the practice subtype. So crop rotation, cover crops, buffer strips, and tillage practices are scored on the nutrient reduction ability. Low scores are represented by high adherence to a best management practice, or the more BMP found within a field, the less potential for runoff. So I'll use buffer strips as a quick example. Large buffer strips with shallow and meandering drainage paths that flow into the buffer strip, flow into the drain, is best for reducing potential runoff. Thus, it's scored low regarding the runoff potential. So when a field is next to a drain, or it contains one, and there's no buffer observed, the field scores high for nutrient reduction potential. So the agricultural intensity is far more straightforward, whereas the scores are based on its potential runoff, and that's simply ranked by crop type over a 3-year period and how much time it was under cultivation. Again, high values represent high potential phosphorus runoff. So all of these layers are then interpolated and then combined using the same process to create the overall nutrient runoff potential per field. So here's a beautiful graphic of the results. This is the Maumee Watershed with the nutrient runoff potential map. The black lines are indicating drainage paths. I just spent so much time and effort on that. I wanted to display it because I think it's really nice looking. So basically this display ramps the result with values from the entire watershed. So the very high values are in reds and oranges. They're more visible here at the scale. It can be seen like clustered in the north. There's some portions over there by Van Wert and Allen and Putnam counties along the southern portion. And also, if you would like to see an example of what these mapped results look like, you could use this QR code to take you to an ArcGIS Online map that you can view the various vegetative buffer components for Putnam County and the interpolated drainage nutrient runoff potential map. And with that,
Well, Kim, why don't you talk a little bit more about what you did there and our work with the Putnam County Soil and Water Conservation District.
Oh yes, quickly. We did work with the Putnam County Soil Water Conservation District to find locations along, I think it was drainage ditches that were the most easily accessible and best likely locations to reduce nutrients at that place. I think Dr. C, if you wanted to add any more to that, you're more than welcome to.
Well, I thought it was a good example where we were working together with the county people and they wanted to do some nutrient reduction practices, and we're along state route, highways and roads. So that with Kim's work, we were able to identify like locations where concentrated flow was going through filters, and that's on the left image over there, also with the red dots. And so Kim's work, she would calculate the area being drained within a field and that path, and then the location in which the water was going through the buffer. So I think that's good.
And then with that,
Thanks, Kim.
yeah, of course, of course. And I think with that, we can probably bounce over to Aaron for his portion of the talk.
Yeah, sounds good. Thanks, Kim. Hi everyone, I'm Aaron. I am a certified ecologist. I've been at GeoWaste for about 6 years now, and PERM has been going on. I guess it's best to start with the introduction of what the PERM is. So it's a parcel-based ecological restoration model. We've been working with the University of Toledo on version 3 of the model, and generally speaking, versions 1 and 2 were kind of started up in partnership and funding from Black Swamp Conservancy, the Land Trust Alliance, and eventually Ohio Department of Natural Resources. And then this university component over the past couple of years was an opportunity to really, in my opinion, just kind of build out PERM version 3 to kind of like a more valuable, elevated to a more valuable state in terms of what you can actually get from practical, from a practical standpoint. So I'm going to go ahead and share my screen real quick and just kind of real quickly cover what PERM is, and then I've got like a 6-minute demo that's going to show you exactly what it does, so you can actually see how it functions. So at the base level, you have parcels. There are over 1 million parcels in the Northwest Ohio region. And what we're trying to do, the goal is to basically take the million parcels and rank them against each other with regard to, specifically, we're talking about best management practices in this webinar. Kim mentioned a lot of different ones in her talk. This is specifically focused on wetland restoration. So where are the places that wetland restoration makes the most sense? So in versions 1 and 2 is strictly from a feasibility or ecological function perspective, kind of answering the kind of the feasibility of putting in a wetland, or where do the environmental conditions exist to, and where are they favorable? Do they have the hydrology, soil, so on and so forth? And in version 3, we took kind of a very intentional turn to talk more about, okay, so we know that piece. So can we answer the question of where are we going to get the most value from it? And so working with University of Toledo has been great to actually kind of start to answer some of those questions from a conceptual sense. So there are a lot of assumptions that go into any model. And the thought is that it's going to give you, the goal of the perm is to give you a starting point as opposed to something that you're going to treat as gospel truth. You need to kind of identify the opportunities and then evaluate those opportunities after the fact. So it's kind of meant to provide a quantitative foundation for kind of what's ultimately a qualitative restoration process that's dependent on people making decisions. Let's see if I can click here. And so specifically in version 3, that we had this, in versions 1 and 2, we had this feasibility matrix. In version 3, we're able to go from one matrix into a more modular approach. That way you could actually set your own goals and based on that, identify your opportunity. So nutrient removal and ecosystem matrices were kind of really hammered out in this particular version. And along with that, working with Dr. Egan over at University of Toledo, we were also able to kind of add some kind of uh, cost benefit analysis. So what's the actual perceived cost per kilogram of phosphorus reduced on any given parcel, taking into consideration the position within the position of that parcel within the watershed. I will start out before I actually get into the demo. If you want to read all 60 to 100 pages of the documentation and chat, I just put the link. You can feel free to go and download that and get a lot more detail than what I'm talking about today. But the demo itself, I pre-recorded because I tend to be a little bit long-winded when I talk about these things, and we have a finite amount of time. So I'm going to stop this share real quick and then start sharing the actual demo. Because I find that I could talk about perm and the model itself, but it just gets really complicated. It's really probably best just to show you what it can do. So hit the escape button here, go over here, and this video is available online as well. This demo here, I can put that in chat real quick just so I don't forget. Looks like I need to put everyone. Thank you, Jill, for fixing that for me. All right, there we go. And I will go full screen and play it.
Demonstrate how the parcel-based ecological. So probably the best way to demonstrate how the parcel-based ecological restoration model works is to just kind of give you a demonstration based on kind of a real-world type use case. So let's just kind of imagine for a second that there is a grant that's made available for targeted wetland restoration within the Maumee River watershed. The primary focus of this grant is nutrient removal with a secondary goal of ecological function. We want the best bang for our buck with regard to nutrient removal, so we're going to kind of take a hard look at that. So with that being said, let's go ahead and hop into the model quick. And I will show you how this works. So you can kind of see here, this is our open source platform, which means that it's license free. Anybody who's given access to Perm basically will see both of these available to them. We're going to load the map up, and the first thing that you're going to see is the footprint of the model. Now there are 1 million different parcels in this particular model, and about 600,000 of them are greater than 1/4 of an acre in size. We've removed everything that's less than 1/4 of an acre. You can still turn that layer on and off, but with regard to the main layer, we've turned them off just for performance reasons. That's still more than we want to look at. We can't look at reasonably 600,000 parcels. So let's go ahead and dial it down. So first off, we can kind of start in our watershed area. So we're in the Maumee watershed. So we'll go ahead and check both of those boxes. You can see right away we went from 600,000 to 84,000 features. And on top of that, our main goal is nutrient removal. So we're going to set a high bar there. we're going to set a high but not as high bar for feasibility, i.e. the potential for successful wetland establishment on a parcel given environmental conditions. And then we're going to set the ecosystem score, right? So we're going to put 50 for that because it's a secondary goal, but it's not as important. But we want to at least make sure it's captured to some degree. And so now, after doing that, you can see that we've gone from 600,000 in a matter of a couple minutes to 62 features. If you want to, if you're an Excel person, you can export it, and it's going to give you a file that Excel likes and you can work with. But we're going to stay on the platform for these 62. So we're going to hit zoom, and then we're going to zoom in just a hair, and you can see anything in green here is what's been identified by the model as matching the criteria that we've established here. So we'll just zoom in on a random parcel here and just take a look so you can see what's included with the perm. And we have feasibility score matrix and nutrient removal matrix and ecosystem matrix kind of front and center here. If you want more details, you can expand any of them out and get more detail to see exactly why they scored the way that they did. Anyway, the other thing that's kind of new, so this nutrient removal score is new to version 3, as well as kind of the ecosystem matrix itself has been teased out in version 3 here. In addition to that, we've also teased out the economic piece. So each parcel has an estimated cost per kilogram of phosphorus reduced. So you can see this one's kind of middle of the road. It's basically in the middle third of parcels within the footprint, and so it's not bad. But we're going to go ahead, and we still don't want to look at 62 different parcels, so we're going to return to our filter and make sure we still have our 62. Yep, we do, and we'll go to data, and we'll just take a look at the table itself, and you can scroll over to the side here, you see this phosphorus reduction cost field. We can actually sort that from smallest to largest. So if we want the best bang for our buck, looks like something weird is going on with this one, so we'll skip to the second one, and we will zoom to it here in a sec. So we've highlighted it, we're going to zoom to it, and there it is. Now if we zoom to the second one, since they're about the same cost, you can see that it's actually in the same cluster here. So this is pretty cool. It presents a unique opportunity, right? Just within our criteria alone, we've actually got 4 parcels that are hitting our criteria in the same area. One parcel is great, but what happens if we have the capacity to restore land on both? So in order to do that, you can see we have a feasibility of 89 and 81 respectively, ecosystem 55, 57, and then nutrient removal of 192. What happens if we can get both of these together? So if you hit selection, you can select 2 of the parcels, or however many parcels you want within the box. Hit, do you want to score them as 1 unit? Yep, absolutely. And now you're going to see that it's going to change, and we have now 3 values here. So the original scores of the individual parcels are already labeled, but then right here you have if both of these parcels are together, and say, wow, that is a great opportunity. We've gone from feasibility score in the 80s to being maxed out. We have a nutrient removal score that's again maxed out. We want to approach maybe it's the same landowner. We want to see if he's interested in selling both of his parcels. So if that's the case, what we can do then is click on this parcel, get all of the specifics about it. The economics will not come through, just for the record, but everything else is basically accurate. So you basically go through at this point, and you can actually export that into your own GIS or whatever. But it's basically giving you, in the matter of 5-6 minutes here, we've gotten a base level of documentation about a very specific targeted use case for these parcels. And so now we can take the information, we can look up the landowner, and we can kind of try to turn it around and make this grant happen. With that being said, that's kind of a brief introduction of what the perm has. There are lots of other tools built into it, but that gives you an idea of what it's capable of.
All right, so That is a 6 minute down and dirty rundown. Oh, I'm gonna turn that off. Down and dirty rundown of the perm and what it does. And I do want to point out the piece that Kim was talking about earlier, the DRP index. I don't think I covered it in the demo specifically. I think that I put a box around the economic component. The runoff index that Kim was talking about, that it was just a hair above where that red box was. So that is a direct aggregated input from Kim's layer. Her model goes a lot finer resolution, and we just rolled it up to the sub-watershed level. If you're interested, it's the Sparrow base or highest resolution that Sparrow offers is the watershed size that we aggregated that up to. So with that being said, that's a little bit about perm and a little bit about what everybody else has been doing. And I'll turn it over to you, Dr. Tchaikovsky, and to wrap us up here.
All right, and I think Kim, yeah, I was going to do that, is sharing our contact information. So you could contact myself, Aaron, or Kim if you have questions about these things. And then Jill, I guess we can do questions and answers. Um, do you want me to just pick
Um,
questions?
well, actually, if you want to, I can handle that.
Okay.
Um, and that way you can have the time to answer. Okay. And feel free, like I'm gonna throw it over to throw out questions to specific people and others just add to those answers. First question that we had gotten was and sorry, now I'm like not finding it fast enough. Um, all right. Well, I'm not doing as well as I thought I was here. Um, how did you include the prediction of phosphate runoff and the amount of fertilizer that has been applied and soil phosphorus test levels in addition to the use of BMPs? And I think this was during Kim, your presentation, or Dr.
Well,
Kwiatkowski.
I could answer is that
Yeah,
we did
go ahead.
not include uh, field observations of nutrients or the runoff. So this was based on the mapping of the management practices and kind of ranking the scores of this is a good management practice, this is not a good management practice. And originally, Kim, do you want to talk about you surveyed people?
Oh, well, originally when we surveyed farmers and what they applied to their fields and management practices,
Yeah.
gosh, that was back in the day. Yeah.
Yeah, but I think that's what you base your the ranking on. Partly
Yes. Oh,
was
yes. Yeah. The reduction potential of the practices themselves was based off of literature and a survey of farmers and what they thought that the reduction potential for whatever practices was given. And it was scored on that system. And when it comes to potential runoff, the agricultural intensity layer is I initially started with just how much corn was planted per field in the past 3 years, but then I was able to take a very high resolution grouped example, like regional example of what's the average amount of pounds per acre that's applied to corn in this section, and took the lower bound of that and use that as a basis point of calculating or at least quantifying a scoring value for how much corn in that field for the last 3 years, how much soy in the field for the last 3 years. So the nutrient runoff potential map itself doesn't have any actual soil test phosphorus data itself incorporated into it. It is purely from what's been observed on the field and through either agriculture intensity via crops or the best practices that have the potential to reduce nutrients.
All right. Well, I have got a couple questions for, I think, Aaron, specifically during your presentation. One question was, has Ohio used PERM in section 319.9 element watershed plans?
To my knowledge, no, they have not. So we have 19 different organizations, I think, currently in there using PERM right now. ODNR is one of them, but I don't think we have any EPA involvement there yet. So it could be that they maybe coordinate with H2 Ohio to some degree, but yeah, I don't, not to my knowledge. The Yeah, I guess that's probably the best way to leave that question. If you want me to expand further at some point, feel free. I'm happy to go further.
And I'll try to add into when I email everyone with the recording, I will add everyone's contact information into that email. So then, folks, if you're interested in following up with any of this team, you'll have those contacts too. Other question that I had, and this again, I think is going to Aaron. What are some of the metrics or inputs associated with the ecosystem score?
Yeah, I'll share my screen real quick. I saw that question, so I was able to pull it up in the documentation itself. All right. Yeah, so the ecosystem score, when you're restoring a parcel, obviously you're generally starting with from literally the ground up, right? So you don't have a lot of, base value ecological function on the land itself. So generally speaking, the ecosystem score takes into higher consideration the wildlife corridors or just the corridors associated with really conservation lands or any kind of green space. So you can kind of see right here, we kind of split it into two different subcategories. One is the habitat itself. So vernal pool proximity, forest proximity, NWI wetlands, protected lands. And protected lands is it's a whole nother talk by itself, but it's also a concentrated effort where a bunch of organizations basically said, hey, we don't have a good, accurate representation of where all of our lands are. Can we all work together and map where these parcels are across Northwest Ohio so we can all kind of work together? That's all in this open source platform we built as well. And it's kind of I think it was version 2 that we built that for everybody. Anyway, the hydrologic connectivity is the other piece. So it's basically doing the same thing. You're looking for a proximity, but with respect to flow paths and actual streams. So how far upstream or downstream as opposed to as the crow flies proximity. As the crow flies proximity is better for like things like, mole salamanders or things that typically don't uh, travel up and down a river or a stream. So that's where we're coming in there. And it's intentionally, I think that there are a total of like 190 points that are actually available in the ecosystem score, but we cap it at 100 with the understanding that, the heavy hitters like designated critical habitat and exceptional cold water designation, those are kind of few and far between. And so we want things to be able to hit that maximum without necessarily having those designations, I suppose. I think I'm good on that one. And I guess one note on the earlier question too about EPA. This is a freely available application. The more people we can get in to use it, the better. So just contact me if you know somebody who would want access to it. The main thing is we just don't want to make it public because there's potentially sensitive information in there. So we want to be able to tell or we want to be able to gauge if this is like a valid use case or not, essentially. So,
All right. I have a three-parter question. And I'll just do each part and then feel free to answer all of you. First question was there anything that you felt was should have been added in this research and you couldn't or weren't able to? Is the first question.
Well, a lot of stuff. So, and I saw Bob Midden's question about the nutrient soil from the fields and things like that. I mean, that would take a lot of work to bring those values in and then checking the actual nutrient runoff in various locations in the watershed. So yeah, those are things that would be cool to do in the future. I don't know,
Okay.
Kim and Aaron, do you have other things?
I always have a running list of a lot of things that I would like to add to perm. As I said before, this is specific to wetlands, and with really a stark shift of the ecological function to when ODNR got involved, the nutrient removal side of things, I would really like to at some point be able to add other best management practices that are targeted around nutrient removal to it. So wetlands are probably the most expensive, per feature to actually implement across the landscape. And so it'd be cool to be able to do the same type of analysis, but for field level BMPs and things like that. So I suppose that would be one thing that I would like to do more. Two-stage ditches, I think would be great. Those kinds of things. So um, that's, I guess, there's also been talk of environmental justice type applications and things like that.
All right. Kim, anything more to add to that one?
Yeah, on my end, I would like to incorporate more best management practice layers overall. So I would like to incorporate the different types of ditches, different types of drainage in field, underground, like tile drains. I'd like to incorporate that one. And then finally, not just for the dissolved reactive phosphorus, but also for nitrogen or any other one that you can use the same model to assess. So nitrogen is the first one off the top of my head. So I'd like to do that in the future.
All right. Was part two, was there anything that surprised you uh, when creating perm? Was there anything in particular that was surprising to you?
Oh boy. Lots of things across the board. Data acquisition is hard, particularly when you're trying to stitch together an entire Northwest Ohio for elevation, and Kim can attest to this, I'm sure. There's a lot of back end data work that goes into particularly the elevation and the flow paths and the roads and how they all or work, I guess not in tandem, but try like the whole of version two, we dedicated an entire year to machine learning and just to detect subsurface flow, culverts and things like that. So I'd say that was probably the biggest challenge that we to date. The national data sets are relatively straightforward because they already cover Northwest Ohio, but the when you have to make data, it that's the hardest thing that I think that we've come across was the elevation type stuff.
All right.
Yeah,
Anything?
my surprise was that Kim could process so many images. It's just really impressive, large data sets. Although I think it was about 4 years ago, we had a RAID 5 failure, and Kim lost a lot of backup information and had to redo things. So, um, yeah, that's my surprise.
Yeah,
All
we went
right.
around to automating it just because of things like that. So yeah.
Yeah.
All right. And there were a part three, you all kind of almost answered it, which was what is the next step to I guess Perm 2.0? What is the next step? Anything additional than what you had already talked about of some of those other things that you would want to add?
We've had some talk here and there. We haven't had anything concrete show up yet. So generally speaking, and this is the way it should be. I mean, we're not in active development of anything currently. And that's largely because I think that we just released version 3 here a few months ago, really in April. So generally speaking, I think people just need to figure out what it has and then kind of what are the gaps now. And that way and this traditionally how it's been is kind of release, wait a year, let's get some more pain points or it would be nice to have, and then kind of we take the most valuable things that we think that would be additions and then add them out afterwards. So
All right. Anything more to add, Dr. Jakowski and Kim?
Well, I'd like, more people are using Perm 3, and I think it'd be really interesting or nice to see it used and then for an application, that through to fruition that, okay, a field was identified, and then a project restoration project was implemented based on that.
Yeah, and I guess with that being said, I agree 100% with version 3. We added a lot of really neat additional functionality to it, and just seeing a kind of cradle to grave use case. We already have some for versions 1 and 2, but I would really like to see this is the first version where we really tackled that watershed position and actually trying to hammer home the value of the nutrients removed out of the waterways and that kind of thing. So I agree with that.
All right. Well, I think we got through all questions. So let me just, if I can, wrap this up since we are right at the time we were thinking. Um, First, I want to thank Dr. Jakowski, Kim, Aaron for their willingness to talk to us today about their research. This is really a great discussion and such a great two HABRI research projects. I did want to remind everyone that the survey URL for this webinar is in the chat feature, so please take a few minutes to fill that out. That always helps us give you great webinars. This webinar series is sponsored by Ohio Sea Grant and will continue next month with Ohio State University's Ryan Winston, who will be discussing nutrient reduction in constructed wetland systems. The registration link is in the chat. Again, I want to thank Dr. Kevin Chakowski, Kim, and Aaron for this great presentation, as well as the participants on this webinar. We hope that this was beneficial and hope you can join us again for an upcoming webinar. Thank you all. Really, thank you so much for your presentations. This was great.
Well, thanks, Jill. Thanks,
Yep.
everybody.
Thanks everybody for attending, and yeah, thanks Jill for having us, and talk soon.
Absolutely. Have a great afternoon.